So today in this session, we're going to be talking about threat modeling, OpenSSL-based systems. A bit about myself, I'm Narayan. People call me Ram, or you guys can call me N2R. That's my coding handle, and I'm a cybersecurity engineer. Thanks for the great introduction. Before we jump onto the slides, quick disclaimer, the opinions expressed in this presentation is all my own, and it does not represent any organization that I'm associated with. So here is the roadmap for today. So we're going to be talking about introduction about threat modeling, then followed by its importance, why it's needed, and key frameworks like Stride and LINDDUN. And we are going to be doing a case study involving a two-tier PKI system. So by end of the slides, by end of the session, you guys should be able to understand what a threat modeling is, why we need it, and how to do it. And we'll be understanding two different threat modeling frameworks. One is Stride, and another one is LINDDUN. Stride is a security-oriented threat model, and LINDDUN is privacy-oriented threat model. You'll be understanding the difference between both of it as well. And we'll be doing a PKI system, SSL-based threat modeling. So what is a threat model? Let's just break the word into two, threat and model. Threat is something, possibility of something that can go bad or harmful, and model is something that can represent or visualize something that cannot be observed directly. So put that together, that's a threat model. A description used to help represent, visualize something that cannot be observed directly. So what is a good threat model? A good threat model is something that enumerates and presents all the high risk harms for the system. Let's say, like, what are all the process involved in the threat, and what are all the process that the threat is coming from. So why do we need a threat model? Threat model it'll help us fix security issues proactively. It'll cost way less when we fix the issue in the designing phase compared to the production. And why are we threat modeling OpenSSL in particular? Because OpenSSL acts as a foundation of trust. And there's a lot of supply chain issues. Even if your application is ironclad, even if your application is like completely secure, but the way you implement OpenSSL is not that great, then your application is ultimately vulnerable to risk. So who all can be involved in a threat model? So anybody who is contributing to the system design. So it's not just for security expert, it should be involving developers, security engineers, who can act as both the defense and the attack, and the product managers, who can bring in the business side of things, as in who can relate the threats and mitigations to the business stakeholders. So everyone who contributes to the system design plays a key role in threat modeling. So, but when can a threat model be done? Threat model is usually done in the design phase, but it's not just during the design phase, it's a continuous process, as in it should evolve per risk or per threat, and it should evolve when you implement a new feature as well. So how do we do a threat model? Our entire presentation going forward is going to be based on this. We're going to be asked 4 questions. What are we working on right now? What are the potential threats? How the attackers can exploit those threats, as in how can we mitigate it, and did we do a good job? So let's take the very first question. What are we working on? So today in our session, we're going to be working on PKI systems, a classic two-tier PKI systems. This is just a reference slide. You guys can refer to it whenever you guys need to. So the core components in our PKI is a root CA, intermediate CA, a CRL, a web server, and a client. These are the security trust components. Root CA here signs the cert for the intermediate CA, and it's completely taken offline after that for security reasons. And intermediate CA acts as the worker horse. So intermediate CA signs cert for all the web servers, mail servers, whatever servers that we try to develop, and which indeed gives us leaf certificate and the certificate chain to the relying party. In our case, the relying party right now can be a client browser. And this browser validates the intermediate CRL and the root CRL for the validity, as in it's going to check if the certificate is valid or it's revoked. So with this system architecture in mind, the key interaction is that relying party trusts the web server certificate, because the web server certificate is trusted by, signed by intermediate cert, which is indeed signed by root CA, and root CA acts as the source of trust for us. So with this understanding, let's go into threat model. That's the next question. What threats can possibly occur in this system? So when we think about this, let's think about a modeling framework. So Stride is a threat modeling framework. It's a security-oriented threat modeling framework, and Stride is a mnemonic for 6 different threat categories. So S stands for spoofing, T stands for tampering, R stands for repudiation, I stands for information disclosure, and D stands for denial of service, and E stands for elevation of privilege. So spoofing, what is spoofing? An attacker claiming to be another user, as in like, hey, I'm a new CA, something like that. And tampering is unauthorized access of modification of data, as in altering any data. Repudiation is somebody denying an action that they did. Information disclosure, this is leaking some sensitive data, and denial of service is disrupting a service, and elevation of privilege is gaining unauthorized access to a system that you don't have necessary access to. So with this Stride in mind, can we come up with a threat model, or can we come up with possible threats for the intermediate CA here? Does anybody have any idea on what how the intermediate CA here can be attacked? As in, like, can it be spoofed, tampered? Does anybody have any idea about it? Let's take, for example, when the attacker presents a self-signed cert, right? Instead of the intermediate CA being the valid cert, let's say there is another rogue CA, and we don't have proper validations in place. The client is by default going to trust that rogue CA, and the system is going to be verified again. But the client doesn't know that it's a rogue CA. So an attacker can spoof to be an intermediate CA in this case. So something like this, can we come up with other threat attack vectors? Like we saw about spoofing, there are tampering, repudiation, information disclosure. Can anything happen in this place? Okay, let's take another example. Let's take denial of service. For example, intermediate CA updates the CRL, right? CRL is certificate revocation list. And the CRL is up to date in this intermediate CA, which is indeed validated by the relying party. So if the relying party tries to validate a CRL, and let's say the older CRL, as in the revoked certs, is not being updated, as in the attacker tries to tamper the intermediate CRL server with empty strings or old certs being validated. With an older cert, the relying party is still going to believe that, hey, this cert is still valid, so I'm going to trust whatever is coming from the cert. Even if the cert is compromised, if the CRL has that cert as valid cert, then it's going to be validated. So do you guys have any other idea on what other things can happen here? Okay, let's take elevation of privilege. So can the CA's privilege be elevated? As in, can relying party become a CA at any point in time? So how does certificate signing works? Any idea on anybody how certificate signing works? Using OpenSSL or any other tool? So typically signing takes place from relying party. That means relying party or intermediate CA. So let's take intermediate CA. It gives a CSR, certificate signing request, to the root CA, which the root CA validates, and then it signs a cert for them, and then it gives the cert file back. So in that scenario, let's take relying party. So CSR is nothing but a file that's going to be sent from the relying party to the intermediate CA in X509 format. So in the CSR, we can have properties like CA:true. If we don't have proper input validations, the CA:true is going to be validated by the cert, and the cert is going to be like, okay, yeah, so they are giving a certificate request for becoming a new CA. And if that certificate request is accepted, then we'll have another rogue CA. I mean, the relying party can have elevated privileges. So relying party's job is to just validate the cert, right? It cannot issue new certs, but in this case, it can. So that is a attack vector again. So something like this. So can we come up with repudiation? Like what intermediate said, what can be repudiated? As in, repudiation is something that the attacker claims to not doing something. As in, he did something, but we don't have enough audit logs to prove that, hey, the attack happened here. Is there any way where we can prove in intermediate cert, hey, can that attack happen? So let's say that intermediate cert, right? Whenever they're issuing a new cert, it'll all be logged. Every cert is after issuance, it should be logged so that we understand what is happening in the system when we go back. So, but let's say the new cert is being logged, but we don't know who is creating the cert or who is requesting the cert, then that log is of no use to the incident responder or the person who's like going through the logs, right? We don't know who's requesting the cert in the intermediate CA, so we should have proper logging structure where we should have like the corresponding person as well, as in the corresponding ID that is requesting the log, or that is corresponding ID that is requesting the cert. So CT logs and audit logs should be present in intermediate CA, that is certificate transparency log and audit logs. Let's go back one slide. So we just spoke about intermediate CA stride, right? Can we come up with something for a relying party? So relying party is the end credit, but that is any browser is a relying party. So as an attacker can have the same browser, they can go to the same website. So what are the possible threats that can happen here? Yeah. Mm-hmm. Yeah, that is very good. Yeah, that is kind of a man in the middle attack kind of thing. But yes, so you can have a self-signed CA, that self-signed certificate, a misconfigured CA. Yes, yeah. That what category do you think that will come under in Stride?
I would say you have spoofing. So if the attacker is using its own CA infrastructure that's not natively trusted by the host, they could get the victim to trust their CA as part of their man-in-the-middle attack.
Yeah, that is spoofing. Yes, that is exactly right. Yeah. Or can that be information disclosure too? I mean, it's spoofing, but how do the attacker know how to spoof it? They need to have a little bit understanding on what the system is designed on, right? So it can come under both information disclosure and spoofing. Yeah. Tampering is when the relying party kind of accesses the intermediate CRL and then makes itself valid. That's when it's tampering. Just the CA is not tampering, but if the CRL is tampered with, I mean CRL is modified, then it's tampering. Yes. Okay, so let's move on to the next step. So till now we saw about STRIDE, that is security-oriented threat modeling. Another powerful methodology is called LINDDUN. LINDDUN is privacy-oriented threat modeling. It's again a mnemonic for 7 threat categories. That is linkability, identifiability, non-repudiation, detectability, data disclosure, unawareness, and non-compliance. So right now, let's just switch the mindset. Instead of talking from security standpoint of view, let's talk about privacy standpoint of view. So LINDDUN is particularly useful for any system that handles personal data. So personal or sensitive data. In this case, let's take linkability and identifiability. And in my opinion, I think these both are way too interlinked with each other, because linkability is like you do a lot of actions, right? Can all the action that you do, can it be linked together? Let's take a real world example. All of you are using different web servers, or all of you are visiting different websites on a daily basis. And let's say that there is a place where you collect all the metadata. Can the metadata be used to link? Can it be used to form a chain? So if it can be, then that is linkability. And identifiability is assigning a profile to that respective data that we gathered. So all the data that is gathered, can it be pointed towards you? As in, can it be assigned a unique value so that you can query it on the later date? That is identifiability. And non-repudiation. Non-repudiation is, can the actions be tracked back to you? Whatever action that you did, can it be tracked back to you? And detectability is, can the activities be detected by an attacker? They don't have to prove that there is an attack, but the attacker doesn't have to prove anything, but can the attacker even detect whatever you're trying to do? If they're able to detect, that's actually a privacy breach, right? Data disclosure. Data disclosure is very similar to information disclosure. Any sensitive data being exposed out of the system, that is data disclosure. And unawareness. This is content policy. I mean, I'm pretty sure everybody's come across this at least once or twice. So whenever you go to a system, you just give, like, open an app, and then you start, when you open an app, it's going to ask you for a list of permissions. Do you know what that permissions are for? Do you have an understanding what the permission is for, or what your information is being used for? If you don't have any, if you don't know the information, or if you don't have any control over the information that the system has, that is unawareness. The user is not aware of what the system is trying to do. And non-compliance. So this is when a compliance is breached. Like, there are privacy compliance like GDPR, CCPA. GDPR is EU's privacy regulation, and CCPA is California Privacy Act. If any of these acts is not being followed properly by the system, that is privacy violation. So with these threat categories in mind, let's assume a scenario for our existing PKI scenario. Let's assume that all the PKI is used in a corporate environment where it's used for email signing and user authentication, as in passwordless SSH and any verified emails. Can we see what all data can be leaked in the system? So this is the model again. So the one change will be the intermediate CA signing cert instead of web server. Let's assume it to be a mail server for this case, and relying party will be an email client. So with that in mind, can we come up with privacy threats? Let's forget about security for a bit, but where all do you think privacy can be breached in this place? A quick example would be every cert that we sign contains a common name. So common name is essential for a cert to be signed, but along with common name, we give common ID. So we don't need a lot of identifiers. We can limit the common name, just one identifier, but even that identifier being there, part of each cert, and when you send a mail to someone, they can see what the identifier is used. So that is a privacy breach. So with that aspect in mind, can we come up with other scenarios as well, like identifiability, non-repudiation, deductibility? Every time you send a mail and that is embedded with your common information, your employee ID. So these are all, and all the recipients in the mail will get all this detail. So that is data disclosure. And whenever you go into a corporate setting, you don't know what your details are being used. Like, every company has their own different policies. You won't understand, or like, no, all the employees are not informed whether their employee ID is being used when they send a mail, or is the employee ID the tracking point, or is the employee name the tracking point, or do they have personal email address? That all can be compliance and non-data disclosure again. So with this in mind, can we come up with other threat categories here?
Without any information about who requests a certificate and all these things?
No, that is a good question. Yeah, we need some information, but we don't need all the information that that is there in the PKI too, right? We need a common name, yes, but let's take auditing. So in the previous stride modeling, I mentioned that, hey, when a cert is being requested, we need to know who requested the cert. That is very true, but that is again leaking privacy data, right? What if those logs are handled by a attacker? They'll get to know who's accessing that machine regularly. Talking about just privacy concerns here. So yeah, I mean, I agree that we need it, but that can ultimately become a privacy concern. Let's say we need just a common name. Organization unit, it's needed on a much larger scale, but if it is not needed, we can probably avoid it, or we can mask the data and audit it. When you are sending the logs, we don't need to send the actual data. We can hash the details and send in the logs. That will probably be a good scenario for privacy and security aspect. Can we come up with any other attack vectors in this space? Let's take passwordless SSH. So we spoke about email right now. So, and certs usually have like your full name, email, employee ID, or subject, domain name, and everything. Can this, I mean, these are all enough information that is leaked in the cert by default, but when it's combined with passwordless SSH, is there any other way we can leak more details, as in, if the cert is being reused for a long time, do you think that can leak any more potential data? Or let's take another scenario where we send encrypted emails. So when we send encrypted emails, the certificate data is still, metadata is still plain text, right? The metadata headers are still plain text. That can still be viewed, which can be eventually used in a phishing attack or a social engineering attack on a later date. So that is one attack vector that we can think about when it comes to privacy.
Can I ask a question? How PKI, because PKI is public, all information in PKI is public. How
Yes.
it's related to LINDDUN? Because if we need request for certificate, we put some public information. Maybe
Yes.
my email, maybe by my name or name of a company. It's how we can protect it. It's because it's related only to policy of CA and
Yeah.
what information we need to put to common name. And
I mean, I'm telling that, yeah, we need necessary information to sign the certificate, so that information is there already outside. I'm telling along with those information, even that information can be used for linking. That is fine, but that information is already out. Are we leaking any other information outside along with that? When auditing, people can audit, like when creating certificate traceability logs or certificate transparency logs, people usually log the key stamp or the time at which the certificate is being requested. That is needed. But do we also need to log the certificate type? Do we also need to log the certificate key? What key is used to log that cert? Which is not really needed, right? So let's see some common things between security and privacy. When we do these two kinds of threat model, what can be the questions that come across? So one major question is like, hey, misconception between these two threat models. So privacy is not equal to security. So just as we discussed right now, a system can be perfectly secure, as in like we can securely generate the cert, but it can still violate privacy on some basis. Even the common name that we're exposing it is still a private, like PII. So that is still getting leaked. So that is a privacy breach. Or let's take a second question, like how do threat modeling approaches differ? So when you do threat modeling using Stride or LINDDUN, what is your mindset going to be? So when you're doing with respect to Stride, we have to think more about the assets, as in the root CA, intermediate CA, relying party, or then we have to talk about the trust boundary. The red lines that is mentioned here are the trust boundaries. We have to check if the trust is broken in the security form of threat modeling. But when you take privacy mode, that is not really the case. We have to just see the data flow. We have to see if the data that is flowing, is it getting leaked anywhere, the private data that you're having. And what is the trade-off between accountability and privacy here? So this is the repudiation and non-repudiation that we spoke about. In the very first Stride model, we mentioned that, hey, we need repudiation, as in we need to log enough data to make sure the attack doesn't happen, or even if the attack happens, we'll need to figure out with enough data. But in privacy, that can again be a boon and a bane. Like privacy can be like, hey, we are logging too much data out of it, so even without an attack, this is a privacy breach where a common name or one single identifier can identify the entire cert list. So for example, if you have multiple certs assigned to your name, with that one common name, if I query the entire log, if I query the entire SIEM database with it, I'll be able to get all the certs that is associated with you, which is like linking more information out of you, right? So summary of this, whatever we saw till date, we saw what a threat modeling is, and we know why it is important right now, and who should do it at what time, and how are we going to do it. So we saw threats, as in like what system are we going to work on, and we analyzed on what the threats can be, and we saw how the threats can be mitigated, and did we do a good job. If we did a good job, we can document the threat model, update it whenever we need. If we didn't do a good job, we can reverse back to the same design diagram. We can add more components to the design diagram, make it more clear so that we can threat model again. And we saw about Stride and LINDDUN, and we saw about the two-tier PKI architecture with threat model right now. So next steps is we have to implement security controls based on the threat model that we did. And there is another threat modeling framework called PASTA, which is a risk-oriented threat model, which is much more complex right now. That is basically, it is a 7-stage process. It's not a mnemonic, but this process basically contains defining the business objective. You define the technical scope along with the business objective, as in then you decompose that application and you do a threat analysis and vulnerability and weakness analysis, and then you do attack simulation. This is the major step in this particular model, and then you do a risk and impact analysis. There are some attacks that you are ready to accept the risk. So the 7th step is that. So the only reason we are not able to do this right now is because of the time constraint. Let's take this diagram for example. We mentioned that, hey, an attacker can spoof, like a relying party can spoof to be an intermediate CA. So in PASTA threat modeling, we'll be analyzing just that. How can the attacker be spoofed? What all mitigations can it happen? So let's just take that example right now. So we mentioned that a relying party can become a CA. And one way to do that is when requesting a CSR, like the CSR can contain the property CA is equal to true. If that happens, then the relying party's end certificate will become a CA, which can issue more certs. So let's just take this scenario. So we define the technical scope right now, and let's decompose the application. When we decompose the application, now we are just focused on the relying party, the intermediate CRL and the intermediate CA, and validity. This is the only thing that we are worried about right now. So with that picture in mind, we know how we can spoof it. How can we mitigate the spoofing? What can be implemented here so that we can mitigate the spoofing? Yeah.
If we use browser, we can use predefined CRL list related to root CA.
Can you repeat that again? Sorry.
If we are thinking about spoofing, we can think about root CA list. I mean, list with public key, public certificate of root CA inside browser.
Okay.
And
that is one way to go by. But
it's a typical way to protect ourselves if we think about spoofing.
Yes, but that is when we have control of the entire system, right? But relying party is something that we don't have control over. Anybody can be a relying party. As in, you can have a client browser, I can have a client browser, I can use a terminal to request a CSR. So if that is happening, how can we protect it against the system? If the intermediate CA is leaked, one good way might be input validation. The CSR that is being sent should be validated. The CSR, like the intermediate CA should validate that, hey, I can only issue end certs, I cannot issue another CA. That can be implemented in intermediate CA right now. But the answer that you gave me was close to it, yes. So these are the references that I used, and the diagram that I created here is using draw.io. This is the tool that I used to design this PKI. But for threat modeling, I would suggest you guys to use either a Microsoft threat modeling tool or OWASP Threat Dragon that can give you more threats and how to analyze these threats and mitigations as well. A good resource would be, and threat modeling is usually conducted over a tabletop exercise as a game. So elevation of privilege is a game, and LINDDUN Go is a game. We discussed about LINDDUN Go right now. LINDDUN consists of Pro and Master as well. LINDDUN Pro is basically defining attack trees. And when you discuss about tabletop games, we can just sit together when having a big room planning meeting, and we can just play a game like, hey, if this system is there, what all attacks can happen? With that, thank you. Do you guys have any questions?
Is it helpful to draw like a boundary around where you're conducting your threat modeling?
Yes. These red lines are the trust boundaries. So we are assuming that there is implied trust between every component inside each boundary. When you're doing straight threat modeling, yes, boundaries really do help. And for this PKI system that we discussed right now, I have a detailed threat modeling report available in the blog. You guys can scan the QR code that will take you to the blog where you guys can see a detailed report on how the threat model looks like. So first it will be defining the assets, then it will be defining the process workflow, post which it will be defining each threat category in a tabular format and what the mitigation can be. And beyond that, it will be on what recommendations are there to fix each threat that we analyzed. So, and the threat model can be updated anytime you guys want to as well. Thank you.
A quick question.
Yes.
Over here.
Oh, sorry.
So there's clearly a push to have reduced certificate life cycles, which is going to result in additional components in this
Yes.
diagram with all of the automation that's coming our way, I think. Do you see that as exacerbating the problem, or do you think these automation points will actually be able to improve the security boundaries between the components?
It might actually improve the security boundaries because if it's completely automated, as in without user intervention, we can add that as a boundary again. We can be like, hey, if the CSR is not coming from this one particular machine or the CSR is not coming from any of these components, you can directly reject it. So that is a good it's a good thing for security, but implementing that is going to be a bit of a task again. So the model should be updated a bit.
Good stuff. Any questions? Any other questions? All right. Thank you, Ram. That was an awesome talk.
Thank you so much.